In today's video, we'll be discussing about Physics Paper 1, MCQ Paper 2024, May June, Variant is 13, and the subject code is 9702. It is recommended that to watch this video in high picture quality. In question number 1, what is equal to this value? So, if we move the decimal place, then 1, 2, 3, 4, 5, and 6. So 5 into 10 to the power minus 6 joules, and 10 to the power minus 6, that is 10 to the power minus 6 is micro. So 5 microjoules. Number 2, the measurement of a physical quantity may be subject to random errors and to systematic errors. Which statement is correct? So what is systematic error? For example, the systematic error for original graph, our original graph must start from a zero value and like this. But for systematic error, what occurs that the readings are consistent, but instead of starting from a zero value, it starts from a value that is above zero or below zero, and the readings are consistent. So the readings are consistent, but instead of starting from zero, it starts from a value that is above or below zero. But for random error, what occurs that for random error, the readings are scattered. So the readings are scattered, but what occurs that if we draw the best fit line for these readings, then the line passes through zero, and the best fit line is same as the original line, that is the original graph. So we can see that the random error can be reduced by taking average. That means if we take the average and draw the best fit line, then the random error can be reduced. So random errors can be reduced by taking average of several measurement. So it can be reduced by taking average of several measurement. And systematic error can be reduced by changing the apparatus or changing the experimental procedure. Number 3, we have given this expression and we need to find which measurement has the largest effect on the uncertainty of this value of the calculated Young modulus. So which measurement has the largest effect on the uncertainty? So approximate change in E by E is equal to approximate change in F by F plus approximate change in L by L, and since it is D square, so it would be 2 into approximate change in D by D plus approximate change in X by X. So these are the approximate change in values and these are the true values. So what is the uncertainty for length? That is approximate change in length by length is equal to this value. Then diameter, so 2 into approximate change in D, so 2 into approximate change in D by D is equal to this value. Then for force, that is approximate change in F by F, then approximate change in X by X. So after calculating these values, we get these values, and which has the largest effect, that means which value is the largest. So the largest value is 0.078. So the correct answer would be B. Number 4, two physical quantities combined together as a product can produce a scalar quantity or a vector quantity. So scalar quantity has magnitude only, while vector quantity has both magnitude and direction. Which product of two quantities produces a scalar quantity? So scalar quantity, that means it has magnitude only and it has no direction. So force into displacement. So force into displacement is the work, and work is a scalar quantity. So the answer would be A. And for the second option, mass into acceleration is force, and force is a vector. Then pressure into area. We know that pressure is equal to force by area. So force is equal to pressure into area. Therefore it is force, and force is a vector. Then velocity into time. So we know that velocity is equal to displacement by time. So displacement is equal to velocity into time. So it is displacement and therefore it is vector. So the correct answer would be A, that gives a scalar, that is work. Number 5, the diagram shows a velocity time graph for an object moving in a straight line. So this is the velocity time graph. What is the displacement during the last 2 seconds of motion? So during the last 2 seconds, that is from 2 to 4, what is the displacement? So we know that area under the velocity time graph is displacement, that is the area under the velocity time graph is displacement, and the gradient of the velocity time graph is acceleration. So gradient is equal to acceleration and the area under the velocity time graph is displacement, and we need to find the displacement during the last 2 seconds. So displacement is the area under the velocity time graph, that is the area of this trapezium. So the area would be half into sum of two parallel sides, that is 6, and 12 into height. So the height is this length, that is from 4 to 2 is 2. So 2 and 2 cancels and the answer comes to be 18. So the answer is C. Question number 6. A block is moving along a horizontal frictionless surface. A constant force F and a constant resistive force of 5 Newton acts on the block as it is moving in the direction of the force F as shown. So this is the direction of movement, this is the forward force, and this is the backward force. The graph shows the variation with time of the momentum of the block. So momentum against time graph, what is the magnitude of force F? So we need to find the force F. So first of all, we know that resultant force is equal to change in momentum by change in time. So what is the resultant force? Resultant force is a change in momentum, that is the initial momentum, 1.5 minus the final, that is 2.7 by time. So we get the resultant force as -3. So this is our resultant force. And what is the resultant force? Resultant force is forward force minus backward force. So forward force is F, that is F, minus backward force is 5 Newton is equal to resultant force. After calculating, we get the value of F as 2 Newton. In question number 7, Newton's third law describes two forces that are equal in magnitude and form a pair. So the forces are equal in magnitude and form a pair. That is Newton's third law. Which description of the two forces in such a pair is not correct? So which description is not correct? So first of all, for Newton's third law, we know that forces are equal in magnitude, forces are acting in opposite direction, and forces are acting in mutually opposite bodies. That means if an object exerts a force on body B, then body B will exert an equal and opposite force on body A. And the two forces are acting in different directions and on different bodies, that is body A and B. And also the forces are of the same type. Same type of forces means that, first of all, type of force means that it can be a gravitational force, frictional force, air resistance. These are the type of forces, or tension force. So these are the type of forces. So the forces are of the same type. That means if an action force is a frictional force, then the reaction force is also frictional force. If the action force is a tension force, then the reaction force is a tension force. That is, the forces are of the same type. So forces are acting in opposite direction on different bodies, and the forces are of the same type, but they cause an object to be in equilibrium. This statement is wrong because it is not mentioned in the third law. Therefore, this option is wrong. So the answer is D. 8. The graph shows the variation with time of the speed of a raindrop falling vertically through air. So the raindrop is falling and the graph shows the variation of speed with time. So which statement is correct? So the gradient of the speed time graph is acceleration. So here we can see that the acceleration decreases to produce a steady speed. So here we can see that the steady speed is produced, and as we can see that the gradient of the graph decreases. So the gradient decreases means that the gradient at this point is this gradient, then the gradient at this point is this line, then this line is this line. So as we can see that with time the gradient decreases, so the acceleration decreases to produce a steady speed. Therefore the correct answer is A. Acceleration increases. This is wrong because we can see that the gradient decreases, so acceleration also decreases. Then the air resistance decreases as speed increases. We know that if a raindrop is falling, then it is falling at a speed of v, and as speed increases, air resistance also increases. So air resistance must increase as speed increases. Therefore this option is wrong. And the resultant force increases as the speed increases. Here we can see that resultant force is equal to mass into acceleration. So as the speed increases, we know that the acceleration decreases. As the speed increases, we can see that the gradient decreases, so acceleration decreases. And as acceleration decreases, the resultant force also decreases and mass is constant. Therefore, the correct answer is A. In question number 9, which statement about a perfectly elastic collision between two objects is correct? So for perfectly elastic collision, we know that momentum is always conserved. So momentum is always conserved. But for perfectly elastic collision, kinetic energy is conserved. So for perfectly elastic collision, only for perfectly elastic collision, kinetic energy is conserved and relative speed of approach is equal to relative speed of separation. That is u1 plus v1 is equal to u2 plus v2. So relative speed of approach is equal to relative speed of separation, and kinetic energy is also conserved. So the total kinetic energy is conserved and the relative speed of approach equals to the relative speed of separation. So the answer is A. And kinetic energy is conserved. Here kinetic energy is conserved, but this is not relative speed of approach is equal to, not equal to. So there is also not, therefore these options are wrong. So the correct statement is A, that is kinetic energy is conserved and relative speed of approach is equal to relative speed of separation, and momentum is always conserved whether it is an elastic collision or an inelastic collision. So we have given two forces. So the two forces are of equal magnitude, that is 3 Newton, acts in opposite direction and whose line of action do not coincide. That means the two forces form a couple. And what is the torque of this couple? That means the magnitude of torque on the tube from the water jet, that is the couple. So what is the torque of the couple? So torque of the couple is the product of one of the forces and the perpendicular distance between the two forces. That is the perpendicular distance between the two forces, that is this distance, and the magnitude of any of the two forces. Since the forces are of equal magnitude, so any of the forces, that is 3 Newton into the distance between the two forces. So this is the torque that comes to be 0.45 Newton meter. So the torque is 0.45 Newton meter. Number 11. An object is held in equilibrium by three forces. The forces all act in the same plane. The diagram shows two of the forces act on the object. So 43 Newton and 17 Newton. The third force is missing from the diagram. What is the third force? So since the system is in equilibrium, that means the resultant force is 0. And at equilibrium, we know that the forces form a closed triangle. So the forces form a closed triangle. But first of all, what is the resultant of 43 and 17 Newton force? So if we draw the exact 40 Newton force at the head of this arrow and 43 Newton force like this, then the forces are equal in magnitude and they have the same angle between them. So this forms a parallelogram, and for this parallelogram we know this angle is 125, so this is also 125, and if this angle is theta, then this is also theta, and the total angle is 360 degree. So after substituting the value, we find the value of theta. Then we substitute the value of theta in this diagram, and here we know the value of theta, and we need to find the resultant of the two forces, that is the resultant of these two forces. So this is the head of this arrow and this is the head of 17 Newton force arrow. So the resultant is obviously in this direction. And what is the magnitude of the resultant force? So we can find this by using the formula. There is a square is equal to b square plus c square minus 2bc cos a, where a is this length and b is this length and c is this length. And here cos a, the angle is cos 55 degree. That is this angle is angle A. And after substituting the value, we find the length of this arrow, that is the resultant of the two forces. So resultant of these two forces is r, and the resultant force is acting in this direction. So since the arrow is in this direction, that is the resultant force is in this direction. That is the resultant of the two forces. So we know the value of resultant force, and to cancel this resultant force, a downward force must act in this direction to cancel this effect of the resultant force and to form a closed triangle. So to form a closed triangle, the downward force must act in this direction, that is this direction, and its magnitude have to be 36 Newton. So 36 Newton and in this direction. So the answer is B. Number 12. The total number of forces acting on an object is 2. So two forces are acting on an object. The object is in equilibrium. Which statement about the forces is correct? So for a system to be in equilibrium, we know that the resultant force is 0 and the resultant moment is 0. So resultant force and the resultant moment is 0. So for an object in equilibrium, the resultant force is 0 and the resultant moment is 0. So which statement about the two forces are correct? The two forces must have equal magnitude. So as the resultant force is 0, so forward force is equal to the backward force, that is the system is in equilibrium, and the resultant force is 0. So the forces must have equal magnitude. The two forces must act in the same direction. So the two forces must act in the same direction. If let's suppose the two forces are acting in the same direction, then here we can see that none of the forces cancel each other out. So it is not in equilibrium and the resultant force is in this direction. But to cancel the resultant force, one arrow is in this direction and the other in this direction, so they cancel each other out. But since they are acting in the same direction, so they form a resultant force which is wrong. Then the two forces must act through the same point. So the two forces must act through the same point. So first of all, we know that the option 1 is correct and 2 is wrong. So 2 is wrong, then 2 is wrong and 2 is wrong, while 1 is correct is in option B and 2 is wrong, while 3 is also correct, that is given. So the answer would be B. So okay, the two forces must act through the same point. So the answer is B. Number 13. The diagram shows the arrangement of atoms in a particular crystal. So this is the arrangement of atoms in a particular crystal. Each atom is at the corner of the cube. The mass of each atom is given and the density of the crystal is given. What is the shortest distance between the center of two adjacent atoms? So first of all, here we have given this diagram, and this diagram is the extended diagram. That means the bonds are extended. But in reality, the atoms are like this. That means the atoms are close together. So the atoms are close together like this. And if we just draw two of the atoms, then the atoms are obviously of equal length. That is, the circles are equal. That means, what is the shortest distance between the center of two adjacent atoms? That is the shortest distance between the center of two adjacent atoms. That is this length, this total length. And this length is radius r, and this length is also radius r. That means this total length is the diameter. Now to find this value, that is the length. So we have given the mass of an atom and the density of the crystal. Now we know that density is equal to mass per unit volume. So density is a ratio. That is the mass per unit volume. If let's suppose the mass is 10 and the volume is 2, then the density comes to be 5. But if let's suppose for a smaller atom, then the mass is 5 and the volume is 1, then the density is also 5. That means the density of an object is constant. So it is constant. So the density is constant. That means whether it is a crystal or a single atom, since mass per unit volume is constant, so mass per unit volume is constant, so density is the ratio and the ratio is also constant. So we know the value of density and the mass. So density is equal to mass per unit volume. So volume is equal to mass per unit density. And here we find the volume. So we know the value of volume. Now this is a sphere. So we know that the volume of the sphere is 4 by 3 pi r cube is equal to this value, that is 3.8 into 10 to the power minus 29. So by using this, we find the value of r, that is, so the value of r is 2.08 into 10 to the power minus 10. Now we know the value of radius, and this length is at 2 radius. So that means 2 radius, so 2r is equal to, or the diameter is equal to 4.17 into 10 to the power minus 10. So 10 to the power minus 10 and 4.17. So 10 to the power minus 10 and 4.17 is approximately equal to 3.4. So 3.4 into 10 to the power minus 10. So the correct answer is C. In question number 14, 4 measuring cylinders are filled with the same liquid to the same height shown. At which point is the pressure greatest? So we know that pressure due to a liquid column is equal to rho g h, where rho is the density, g is the gravitational field strength, and h is the height of the column. So since they are the same liquid, so the density is same and gravitational field strength is constant, that is 9.81 for Earth. So pressure is directly proportional to height. So as height increases, pressure increases. So at this point, the height of the liquid above this point is 10 centimeter. So the height is 10 centimeter. For this point, the height of the liquid above this point is 0. Then for this point, the height of the liquid above this point is, this length is 10. So this length is 10, that is given, and this length is 30. So the height of the liquid above this point is 20 centimeter. That is 30 minus 10, that is 20 centimeter. And for this point, the height of the liquid above this point is 0. So the correct answer is B, that is B has the greatest pressure. 15. In many filament lamps, as much as 92 joule of energy is emitted as thermal energy for every 8 joule of energy emitted as light. So that means 92 is thermal energy and 8 joule is light. That means that total energy is 100 joule, and from this 100 joule, 92 is thermal energy and 8 joule is light. What is the efficiency of the filament lamp as a percentage of the electrical energy converted to light energy? So what is the electrical energy that is supplied? That means the total energy that is supplied. So total energy is 92 plus 8, that is 100 joule of energy that is supplied. So percentage is equal to, or efficiency is equal to useful energy output by total energy in 100%. So useful energy by total energy, so the total energy is 100 joules, so 100, and the useful energy output, so it is a filament lamp converted to light. So light energy is our useful energy output, that is light energy is 8 joules. So 8 by 100 into 100%, so this is approximately 8%, or the value is 8%. 16. What is the unit of power? So power is equal to energy by time, or the work done per unit time. So the unit of energy is joule and the time is second. So joule per second. So the answer is D. For question number 17, an object in a uniform gravitational field, the graph shows the change in the gravitational potential energy of an object varies with the vertical distance x moved by the object from a fixed point. So gravitational potential energy against x graph. Which graph shows the gravitational force acting on the object varies with distance x? So gravitational force against x. So gravitational potential energy against x. So we can write this equation in the form of y is equal to mx plus c, where we can see that the graph starts from 0. So the y-intercept c is 0. So y is equal to mx and y-intercept is 0. So y is equal to mx, where m is the gradient and y is the gravitational potential energy. So EP is equal to mgh, and here the height is distance x. So instead of height, we write this as distance x. So mgx. So here we can see that gravitational potential energy is equal to mgx, and here we can see that the gravitational potential energy is equal to mgx, where gravitational potential energy is y and x is the x-intercept, x-axis. So that is the distance. So mg is the gradient. So m is the gradient, that is mg is the gradient, and we know that mg is the mass into gravitational field strength, or we can say that force is equal to mass into gravitational field strength. So this gradient is force, and since the gradient is constant, so force is also constant with distance. So gradient is constant, so gradient is constant, and we know that gradient is equal to force. That means force is constant, or the force value is same. So the force value is same or it is constant. So the answer is C. Number 18, a block of mass 2 kg. So the mass, we have given the value of mass, is released from rest. So initial speed is 0. So u is equal to 0. It travels 7 meter down the slope and falls a vertical distance of 3 meter. So the distance is 7 meter and the vertical distance is 3 meter. The block experiences a frictional force parallel to the slope of 5 Newton. So since it is moving downward, so the frictional force must act upward, that is 5 Newton. And what is the speed of the block after falling this distance? So speed after falling this distance, that is v. So to find the value of v, we have given the value of u. So first of all, what is the acceleration? So if we just label this diagram, then 2 kg, so the weight is 2 into g, that is acting vertically downward. So the weight is 2 into g, where g is the gravitational field strength, and weight is equal to mass into gravitational field strength, that is 2g. So this angle is 24 point. So first of all, where we have given the value of 2g, so 2g cos theta and 2g sin theta, where this angle is theta, and we know that this angle is equal to this given angle. And what is this angle? So we have given 3 meter and 7 meter. So by using this, we have given the value of opposite and hypotenuse. So sin theta is equal to opposite by hypotenuse. So value of theta is 25.4. So 25.4, we have given the value of theta. Now, we know that the resultant force is equal to mass into acceleration, or resultant force is equal to forward force, that is 2g sin theta, minus backward force, that is 5, is equal to mass into acceleration. So by using this, we know the value of sin theta, we know the value of theta and the gravitational field strength, that is 9.81. So by using this, we find the value of acceleration. So we know the value of acceleration, and we know that initially it starts from rest. So initial speed is 0, and the distance that is traveled is 7 meter. So 7 meter, that is this distance traveled, and we need to find the speed of the block after falling this distance, that is v. So speed v. So by using the equation v square minus u square is equal to 2as, we find the value of v, that is 4.88, or approximately 4.9 meter per second. So the answer is A. 19. Two wires, one made of brass and the other made of steel, are stretched in an experiment. Both wires obey Hooke's law. So Hooke's law means that force is directly proportional to extension. So force is directly proportional to extension means that that means the force is directly proportional to extension. That means the graph is a straight line and there is no curved section. That means there is no limiter proportional to elastic limit. That means there is no limiter proportional to elastic limit. The graph should have to be a straight line. There is no curved section in the graph. That is, force is directly proportional to extension. So the graph have to be a straight line graph. That means there is no limiter proportionality or elastic limit. The Young modulus for brush is less. So Young modulus for brush is less than for the Young modulus of steel. Which graph shows the stress varies with strain for both the wires in an experiment. So we know that Young modulus is equal to force per unit area extension divided by original length. Also, Young modulus is equal to stress by strain. So stress by strain. And here we have given the brush has less Young modulus than steel. That means steel has more Young modulus. Steel has more Young modulus. So suppose for steel, the Young modulus is more. Since the Young modulus is more, that means the stress is more per unit strain. That means for a given value of strain, the stress is more for steel. So stress is more for steel, but for a given length, the stress is less for steel. Therefore, it is wrong, and the correct answer is B. That is, since the Young modulus of steel is more, so Young modulus is more. That means for a given value of strain, the stress value is more. So suppose for a given value of strain, that is either this point or this point, suppose at this point, for a given value of strain, the stress is more for steel. So for steel, the stress is more, so Young modulus is more, and the answer is B. Number 20. A sample of material is stressed by tensile force to a point beyond its elastic limit. The tensile force is then reduced to zero. The force extension graph is shown, which area represents the net work on the sample. So first of all, it is extended beyond its elastic limit. And let's suppose this is the limit of proportionality and this is the elastic limit. So before the elastic limit, that means this is the limit of proportionality and this is the elastic limit. So elastic limit. So before the elastic limit, elastic deformation occurs. That means elastic deformation occurs that the wire returns to its original length. Before the elastic limit, the wire returns to its original length. But after the elastic limit, the wire does not returns to its original length, that is the extension 0, and it returns to a point that is greater than 0. So after elastic limit, plastic deformation occurs. So after elastic limit, plastic deformation occurs. So plastic deformation occurs that the wire does not return to its original length. So after elastic limit, plastic deformation occurs. So here we can see that the plastic deformation occurs. And what is the net work done? So work done to extend the wire is, the total work done to extend the wire to this point is x plus y plus z. And what is, that is the total area, x plus y plus z. And from this point, the wire returns to some length. So the work done to return the wire is this much work. That is the area under this region. That is region Z. So what is the net work? Net work is the total work minus the work that is returned. So x plus y and plus z coincides with minus z. So the net work is x plus y. 1. A wire is fixed at one end and is extended by force F1 acting on the other end. This causes the wire to have an elastic potential energy of 0.15 joules. The force applied to the wire is now changed to force F2. This causes the wire to have a new elastic potential energy of 0.60 joules. The wire obeys Hooke's law, that is, force is directly proportional to extension. What is the relationship between force F1 and F2? So we know that elastic potential energy is equal to half Fx or half kx square, where x is the extension and k is the constant. And we also know that Hooke's law is equal to force. Force is directly proportional to extension. That is, force is equal to constant into extension. So force is equal to constant into extension. So we have given the value of energy and the value of force, that is F1. Also energy and force F2. So we don't need an extension in the equation, but if there is a constant, then constant is constant for both the equations. So we can cancel this out. So if we write this equation, then F is equal to kx. So k is equal to F by, or x is equal to F by constant. So extension is equal to f by constant. Since we don't know the value of extension, so we can substitute the value of x in this equation, that is half f into f by k. So we can write this equation as half k f square. Now for this equation of elastic potential energy, we know that k is a constant, so it is a constant, and half is also constant. That means elastic potential energy is directly proportional to f square. So elastic potential energy is directly proportional to f square. So we can solve this by ratio. So u1 by e2 is equal to f square 1 by f square 2. That is u1 by e2 is equal to f1 square by f2 square. So after solving, f1 square by f2 square is equal to 1 by 4, or simply f1 by f2 is equal to 1 by 2 after solving. So we can see that if we write this clearly, then 2f1 is equal to f2. So 2f1 is equal to f2, that is answer C. 2f1 is equal to f2. The diagram shows a representation of a wave on the screen of an oscilloscope. The Y gain is set to 3.5 millivolt per centimeter. That means this length is 3.5 millivolt. So this length is 3.5 millivolt per centimeter. That is 1 centimeter is equal to 3.5 millivolt. So what is the amplitude of the wave? So amplitude is equal to this length. That is 2 box. So 1 box is 3.5. So 2 box is equal to 3.5 into 2. That is 7. So 7 millivolt. So the answer is question 23. A transverse progressive wave on a string has a wavelength given and the amplitude is given. The speed of the wave on the string is given. What is the distance traveled by a point on the string in the time of 2 seconds? So this is the duration of movement of the wave. And for a single point, so what is the distance traveled by a point? So for a single point, the wave is moving in this direction, while for a point, the point moves only up and down. So up, then down. So the duration of the movement of the wave is in this direction, while for the duration of movement of a point or a single point is up and down. So that means for suppose this point moves up, then down, then again down, then again up to complete one complete cycle, or we can say that one complete wave. So up, then down, and then up to complete one complete cycle. So one complete cycle. So we have given the wavelength and the speed. So we know the equation V is equal to f lambda, and instead of f, we can write that we know that frequency is equal to 1 by time period. So 1 by time period into lambda. So what is the value of time period? That is the time taken for one complete wave or one complete oscillation. So one complete wave or one complete oscillation. So the time period is lambda by V. So lambda by V, that is the lambda is 12 by V, that is 48. So 12 by 48. So the answer comes to be 0.25 seconds. So for one cycle, the time is 0.25 seconds. So for 2 seconds, what is the number of cycle? That is x. So what is the number of cycle? And this is time seconds. So for 2 seconds, what is the number of cycle? So for 2 seconds, the number of cycle that comes to be is 8. So x is equal to 8. That is 8 cycles. That is the point covers 8 cycles. And for each cycle, we know that it moves up, then down, and then up to complete one complete cycle or one complete wave. So for one complete cycle, it moves up, then down, then again up. So what is the distance covered? So for one cycle, the distance that is covered is, the amplitude is 1.5 meter, 1.5 centimeter. So 1.5 centimeter up, then 1.5 down, then 1.5 again down to reach the bottom point, then again up to 1.5. So what is the total distance covered in for one cycle? So 1.5 into 1, 2, 3, 4. So 1.5 into 4. So the total distance covered is 1.5 into 4, since 1, 2, 3 and 4. So 6. So 6 centimeter. So the total distance is 6 centimeter. So for one cycle, the distance that is covered is 6 centimeter. 6 cm. So for 8 cycle, the distance that is covered is 8 into 6 centimeter. So the answer comes to be 48 centimeter. That is answer C. So this is the movement of a point, not the movement of the wave, and the point moves up, then down, and then up to complete one complete cycle or one complete wave. Question 24. An ambulance siren emits a sound with a single frequency F. The ambulance travels towards and passes close to and then travels away from a stationary observer, which statement describes the frequency of the sound generated by the observer as the ambulance passes the observer. So we know that FO is equal to FSV, V, FSV, then V plus minus Vs. And if the object moves towards the observer, so if the object moves towards the observer, then FO is equal to FSV, V minus Vs. And if the object is moving away from the observer, then FO is equal to FSV, V plus Vs. So towards minus away plus. So FO is equal to FSV, V plus Vs. And the ambulance travels towards, passes close to. So towards and passes close to, they like this is our observer, and the ambulance passes towards close to and then travels away from the stationary observer. So since it passes close to, that means the frequency is equal to FO. So the frequency is equal to F, that is the original frequency. So the frequency is equal to F, where Fs is the frequency of the source of the original frequency. So the frequency is equal to F, and since the object is moving away from the observer, so since it is moving away, so here we can see that as it is moving away, the denominator increases, so the observed frequency decreases. So the observed frequency decreases, therefore it is decreasing. So the answer is A. Question 25. An electromagnetic wave has a wavelength of 138 picometer in the vacuum. So 138 picometer, that is 138 into 10 to the power minus 12 meter, or 1.38 into 10 to the power minus 10 meter. To which region of the electromagnetic spectrum does this wave belong to? So you must remember or memorize these values. That is radio waves 10 to the power 4 to negative 1, then negative 1 to negative 3, negative 2 to negative 6, 4 into 10 to the power minus 7 to 7 into 10 to the power minus 7, then negative 7 to negative 9, negative 9 to negative 12, and negative 10 to negative 16. So obviously 10 to the power negative 10. So 10 to the power negative 10 is negative 9 to negative 12 or negative 10 to negative 16, either these values. So it is not radio, that is the first. Then micro, that is the second, this is not the second. And this is also not the visible light, that is 10 to the power minus 7. So it is X-ray. If it is X-ray, then X-ray is 10 to the power minus 9 to 10 to the power minus 12. So 10 to the power negative 9 to negative 12, that is 10 to the power negative 10 is in between these values. So the answer could be D. And the answer is D. 26. A student investigates the polarization of microwaves. The microwave from the transmitter are vertically polarized. That means the microwave from the transmitter are vertically polarized. So they are the vertically polarized, and the metal gray is acting as a polarization filter when placed between the microwave transmitter and the receiver. The reading on the voltmeter is proportional to the intensity of the microwaves transmitted through the grill. So intensity is proportional to intensity. So the reading on the voltmeter, that is the voltage reading, is proportional to the intensity. So the voltage reading is proportional to the intensity. So when the transmission axis of the grill is vertical, the voltmeter reading is this value. So when the transmission axis is vertical, that means initially vertical waves are traveling, and when the transmission axis is vertical, no waves are deflected. Since the waves initially traveling vertically, and when they passes through the axis, they travel vertically, since none of the waves are deflected, since the axis is vertical. Since the axis is vertical, so none of the wave is deflected, and it is we get the maximum intensity, that is the maximum intensity. So when the intensity is maximum, we get this volt. So intensity is direction proportional to voltage, that is I1 by I2 is equal to V1 by V2. And what is the I1? I1 is the maximum intensity, that is this maximum intensity, and V1 is this voltage, that is 3.5. And for when the grill is rotated to an angle theta, the voltage is this value. So we get the value of voltage for the second voltage. And what is the next intensity? I2. So what is I2? So we know the formula, that is the Mallows law, that is I is equal to intensity maximum cos square of theta. Cos square of theta. So instead of I2, I can replace this, that is IO cos square theta, or intensity maximum cos square theta. So IO cos square theta, where this that is the maximum intensity cancels with the maximum intensity, and cos square of theta is equal to 0.62. So what is the value of theta? So the value of theta comes to be 37.54. So 37.54 degree, that is approximately 37.5 degree. Question 27. Two waves superimpose. The resultant wave pattern is formed. Which statement about the two waves must be correct? So they have the same amplitude. So for the same amplitude, if the two waves let's have the same amplitude, then this condition is needed for distributive interference, because for distributive interference the two waves must cancel and to form a wave that of zero amplitude. So if the two waves are of the same amplitude, then the waves cancel and distributive interference occurs. So this is not the condition for superposition. Then they are of the same type. Yes, the waves are of the same type is needed for superposition. So this is the condition for superposition, that is the waves are of the same type. Then the waves are transverse. This is needed for polarization. That means only transverse waves can be polarized and longitudinal waves cannot be polarized. So only transverse waves can be polarized and longitudinal wave cannot be polarized, and they travel in opposite direction. So this is wrong. Then coherent. So coherent is needed for interference. If let's suppose the waves are coherent, then interference occurs. If the waves are not coherent, then no interference occurs. Question number 28. A water wave passes through a gap in a harbor and diffracts. The gap has a weight of 8 meter, so 8 meter harbor wall, duration of wave transfer. The wave travels directly towards the gap, for which wavelength is the diffraction of the wave greatest. So diffraction is greatest when the weight of the gap is approximately equal to the wavelength. So the weight of the gap is approximately equal to the wavelength. When the weight of the gap is approximately equal to the wavelength, the diffraction is the greatest. So which length is approximately equal to the wavelength? Approximately equal to the gap. So 8 meter is approximately equal to the gap. That means the diffraction is the greatest when the wavelength is 8 meter. Question 29. Light of wavelength given from a laser is incident normally on a diffraction grating. So the light is incident on the diffraction grating. The diffracted light is incident on a semicircular screen as shown in the view from above, that a total of 9 bright dots are formed on the screen. So the total number of dots that are formed on the screen is 9. The grating is at the center of the semicircle. So this is the grating. The lines of the grating are vertical and the separation between the adjacent lines in the grating is d. What is the possible values of d? So to find the value of d, first of all, there are 9 bright dots. So a total of 9 bright dots. That means the total number of dots is 9. So if we just drop, then this is 1, then this is 2, 3 and 4. So basically first of all we need to make 9 dots. So first of all 1, then 1, then 1. So 3, 4, 5, 6, 7. 3, 6, 7. But if we just then increase, then the dots would be like this. So 3 is a 6, 3 is a 9. So these are the 9 dots. That is a total of 9 dots are formed on the screen. So the total number of dots that are formed on the screen is 9. So now we can use the formula d sine theta is equal to n lambda, where we need to find the value of d. So d is equal to n lambda by sine theta, where what is the value of n? So n is the number of dots from the center. So this is the center dot. And what is the number of dots from the center? So 1, 2, 3 and 4. So 4 into the lambda by sine theta. So from this center, what is the value of theta? So from the 0th order, the value of angle is 90 degree. So sine 90. So after substituting the value, we get an answer of 2.2 into 10 to the power minus 6. That is approximately equal to 2.25 into 10 to the power minus 6. So the answer is 30. Which quantity is given by the product of charge and electric potential difference? So charge, that is Q, and the potential difference is V. So charge into potential difference, that is VQ. So looking at the options one by one, current is equal to charge by time. So here is a common, that is charge, but we cannot convert time to voltage. Therefore this is wrong. Currently this is wrong. Then for the second option, energy is equal to, we know that energy is equal to power into time, that is voltage into current into time. And we know that voltage into current into time, so we can convert, instead of current we can put charge by time, that is V into Q by time instead of current into time. So time and time cancels and the answer comes to be VQ. So the answer is B. And power itself is not the answer because it is the energy, and resistance is equal to voltage by current, that is I, and we cannot convert I to Q. Therefore, this option is also wrong. So the correct answer is B. Question number 31. The current in the filament lamp is increased. So current increases. Which statement about the lamp is correct? So as the current increases, due to increase in current, the brightness increases. So the brightness increases, and as brightness increases, the temperature of the filament lamp also increases. Temperature also increases, and increasing the current, the potential difference also increases. And for resistance, we know that current is equal to charge by time. So initially, less charges flow through the wire, but as the current increases, charge also increases, so more charges flow. Due to more charges flow, the resistance also increases. So resistance increases due to more charges flow. Therefore, the according to the option, the correct answer is D. That is, the temperature of the filament lamp increases due to increase in current. 32. A student builds the circuit shown. All the lamps are identical. Which lamp dissipates more power? So since the lamps are identical, that means all have the same resistance, that is the value of R. So all have the same resistance, and which lamp dissipates more power? So we know that power is equal to voltage into current. Power is equal to I square R, and also power is equal to V square by R. So the equation connecting resistance and current is power is equal to I square R. So power is equal to I square R, and all the lamps have the same resistance, so the resistance is same. Now, which lamp gets the more current? So here current travels, then current is divided between the two circuits junctions, and then again joins. So the more current is in option D, therefore the more power is in option D, and the resistance is same, but the more current is in option D, so the more power is in option D. So the answer is D. In question number 33, the resistance of a metal cube is measured by placing it between two parallel plates as shown. The cube has a volume V and is made of the material of resistivity ρ. The connection to the cube has negligible resistance. Which expression gives the electrical resistance of the metal cube between x and y? So we know that resistance is equal to resistivity into length by cross-sectional area. And all of the answers are given in terms of resistivity and volume. So we need to convert length and area to volume. So first of all, for a cube, we know that cube has a volume that is L cube. So volume of the cube is L cube. Then area of the cube is L square. So if we convert L to volume, then length would be equal to, so volume to the power 1 by 3 into length to the power 1 by 3. That is, the length is equal to 3 and 3 cancels, and length is equal to volume to the power 1 by 3. So length is equal to volume to the power 1 by 3. And if you convert length in terms of area, then length is equal to area to the power 1 by 2. So length and length. So length and length are equal. So area to the power 1 by 2 is equal to volume to the power 1 by 3. So by using this, we convert area to volume. So if we multiply both sides by 2, then area to the power 1 by 2 into 2 and volume to the power 1 by 3 into 2. So area to the power 1, that is area is equal to volume to the power 2 by 3. That means length is equal to volume to the power 1 by 3 and area is equal to volume to the power 2 by 3. So we convert length and area in terms of volume. Then if we just substitute, then resistance is equal to resistivity into length. In terms of, instead of length, we substitute volume to the power 1 by 3, and instead of area, we substitute volume to the power 2 by 3. So after substituting the value, we get the value of resistance, that is resistivity by volume to the power 1 by 3. So resistivity by volume to the power 1 by 3 is an option C. So the correct answer is C. Number 34. A circuit needs to be completed by connecting two resistors between points X and Y as shown. The resistors can be connected in series or in parallel with each other. Which combination of resistors produces the least resistance between X and Y? So which combination produces least resistance? So since the resistors are arranged in series, so in series we know that resistance are added. So if we just add the resistance, then 20 plus 40 is 60 and 40 plus 100 is 140. So this is the resistance. And for parallel combination, you can do calculation, but you need to remember that when two resistors are arranged in parallel, suppose when two resistors are arranged in parallel, that is this resistor and this resistor, if the two resistors are arranged in parallel, then the combined resistance, that is R combined, would be less than the least resistance. The resistance of the combined resistor is less than the least resistance. That means for option A, if we look at the resistance values, then 20 and 40. So the resistance of the combined is less than the least resistance, that is the resistance of the combined is less than the least resistance, that is 20. So resistance of the combined is less than 20, and if we just calculate that resistance of the combined is equal to, by using the formula, if we just calculate, then 1 by 20 plus 1 by 40 inverse. So by using this formula, by using the formula that we know, the resistance comes to be 13.33 ohm, and we use the formula that is 1 by R total, that is the resistance combined is equal to 1 by R1 plus 1 by R2 for parallel combination. So by using this answer, we can conclude that the resistance of the combination is less than the least resistance, that is the least resistance is 20, so the resistance of the combined have to be less than 20. Similarly, for option B, the least resistance is 40, so the combined resistance have to be less than 40. So the combined resistance have to be less than 40, and if we just calculate by using this formula, so the resistance of the combined comes to be, after using this formula, is 28.57. So here we can see that the resistance of the combined, that is the resistance of the combined is less than 40, that is the resistance of the combined is equal to 28.57. So you must remember that the resistance of the combined for parallel combination is less than the least resistance. So by using these options, the correct answer is A, that has the least resistance. Number 35. The diagram shows a circuit that includes a cell with internal resistance. So this is the circuit. The switch is initially open. So the switch is open, which describes the effect of current I1 and I2 of closing the switch. If we just close the switch, then the two resistors are given, and if we just consider the resistance of the two resistors as R, then initially when the switch is open, when the switch is open, the resistance is R. If we neglect this resistance, then the resistance is R. But when the switch is closed, the combined resistance is 1 by R combined is equal to 1 by R plus 1 by R. So after calculating, we can say that the resistance of the combined after the switch is closed, the resistance decreases. We can see that after the switch is closed, the resistance decreases, that is R by 2, but initially it is R. So when the switch is closed, the resistance decreases. Since the resistance decreases, so the total current must increase. Since the resistance decreases, so the total current must increase, that is I1 increases, which is the total current. And this I1 current is divided to I2, and suppose this is I3. So since it is divided, so the current I2 is initially getting I1. But now since it is divided, so it gets less current. So the current decreases. So the correct answer is C. Number 36. The diagram shows a circuit consisting of a cell and three resistors R1 and R2 and R3. So R1, R2 and R3. The cell has an EMF 1.6 volt and negligible internal resistance. So negligible internal resistance. The circuit in the cell is 0.64 ampere. So 0.64 ampere. The potential difference is 0.48 volt for R1. So the voltage of R1 is given. The current in R3 is given. And what is the resistance? R2. So we need to find the resistance R2. So first of all, here the current is given, that the total current. This total current is transferred to this junction, that is 0.32. So what is the current in this junction? So 0.64 minus 0.32. So 0.64 minus 0.32. So the answer comes to be 0.32. It is 0.32. Since current is divided, so 0.32 goes to this junction and 0.32 goes to this junction. So the total current is divided between these two junctions. Now we know the total current. So since these two resistors are arranged in series, so the current value is same. And the total potential difference, since this resistor, this two resistor and this resistor are arranged in parallel, so the potential difference between the two parallel combination is 1.6 volt and 1.6 volt since they are in parallel. So the total voltage is 1.6 volt and this is using 0.48 volt. So what is the voltage for R2? So 0.48 volt. So 1.6 the total voltage minus 0.48. So the voltage of R2 VR2. So the voltage of R2 comes to be 1.6 minus 0.48. So the voltage comes to be 1.12 volt. So the voltage is 1.12 volt and the current, since these two are in series, so the current is same, that is 0.32 ampere. So resistance R2, RR2 is equal to voltage, that is 1.12 by current, that is 0.32, 0.32. So the resistance comes to be 1.12 by 0.32. So the resistance is 3.5 ohm, 3.5 ohm. So the correct answer is C. Question number 37. The diagram shows a potentiometer circuit used to compare the EMF E1 and E2 of the two cells. So the EMF E1 and E2 of the two cells, XY, is a uniform resistance wire. So XY is a uniform resistance wire. The fixed resistor R, the fixed resistor has a resistance R. The sliding contact is moved along the wire XY. When the sliding contact is at position P, the galvanometer reading is 0, or the galvanometer reads to 0. So when the sliding contact is at position P, galvanometer reading is 0. That is, when it is at P, galvanometer reading is 0. The circuit is changed so that the galvanometer reads 0 when the sliding contact is at the new position to the left of P. Now, the galvanometer reading is still 0, but the sliding contact is moved to the left of P and at this length, suppose at this length. So, which change have been made to the circuit? So here we can see that the length of XP decreases. So length XP decreases. Since the length of XP decreases, here we can see that now the sliding contact is at this point. So the length of XP decreases. So resistance of XP also decreases. And since resistance of XP decreases, so voltage of XP also decreases. Voltage of XP also decreases. So basically, now for the second condition, voltage of XP decreases. This is a given condition that the voltage of XP decreases due to decrease in length. And we know that E2 by E1 is equal to the voltage XP, that is the voltage XP by the voltage XY plus the voltage at R. So E2 by E1 is equal to voltage XP by voltage at R plus voltage XY. And we know that for the second condition, the voltage across XP decreases due to decrease in length. And to make the galvanometer reading 0, we need to increase the upward side to make the equation constant. So basically we need to increase the above part. So the wire XY was replaced with one of lower resistance. So this wire XY is replaced with one of lower resistance. Since the resistance across XY decreases, so voltage across XY also decreases. So the voltage across XY decreases. Okay, the voltage across XY decreases. Now XP is also the part of XY. XP is also the part of XY. So since the resistance of XY decreases, so XP is also the part of XY. Therefore, the resistance of XP also decreases. XP also decreases. Since the wire is changed with a lower resistance. So due to lower resistance, for this wire, the resistance of XP also decreases. So basically of lower resistance, due to lower resistance, the resistance across XY decreases. Due to lower resistance, the resistance across XY decreases. Therefore, the voltage across XY decreases. Similarly, the wire XY, from the wire XY, XP is also the part of XY. So if the resistance of XY decreases, so the resistance of XP also decreases. Since the resistance of XP decreases, so the voltage of XP also decreases. So the voltage of XP is also decreases. So here we can see that the upward side is decreased by a factor of 2, while the downward side is by a factor of 1. Therefore, they do not cancel each other out. Therefore, the option 1 is wrong. So the option 1 is wrong. Then E2 was increased. If we increase the value of E2, then E2 is multiplied with the denominator and E1 is multiplied with the numerator. So here we can see that the denominator has increased, but to cancel this decreased effect, we need to decrease the denominator. That means we need to decrease E2, not increase E2. Therefore, the option B is also wrong. Now for the third option, E1 was decreased. So E1 has decreased. Now E1 is decreased and E1 is multiplied with the numerator. So here we can see that there is two decreasing effect. So due to this two decreasing effect, that is decreasing in E1 and decreasing XP, voltage in XP. Therefore, they do not cancel. Therefore, the option C is also wrong. Due to twice the decreasing effect and there is no cancellation, therefore the option C is wrong. But for option D, here the resistance R was decreased. So now the resistance R is decreased. Since the resistance of R decreases, so the voltage across R decreases. So the voltage across R decreases, and since the denominator decreases, so this decrease in voltage cancels with this decrease in upward voltage. So this denominator cancels with this numerator decrease. So decrease cancel, and the ratio or the equation becomes constant. So yes, the answer is D, that when the resistance of R decreases, the voltage across R decreases, and since the voltage across R decreases, so this decrease in effect cancels the XP decrease in effect, so the overall equation becomes constant. So the answer is D. 38. Nucleus P has 144 neutrons and 93 protons. Nucleus P is unstable and undergoes alpha decay to form nucleus Q. So nucleus P is unstable and undergoes alpha decay to form nucleus Q. So P, and so the total number of protons is 93 and the neutron plus proton, that is the nuclear number is, so the nuclear number is 237. There is a number of protons plus number of neutrons, and P decays by alpha decay. So alpha particle is emitted and the alpha particle is forced to form the nucleus Q. So Q, so 4 and 2, so 2 protons in alpha, so 93 minus 2, that is 91. For Q, the number of protons is 91, the number of nucleon is 237 minus 4, that is 233. 233. So 233 and 91. Now Q then undergoes beta minus decay to form nucleus R. So by beta minus emission, so 0 nucleon and -1 charge, since it is -1, beta minus, so -1. So we can say that the proton number increases by 1, that is 92. So R and 233. Since 233 minus 0 is 233 and 91 minus -1 is 92. So it forms R. So Q undergoes beta minus decay, that is beta minus, to form R, beta minus and antineutrino plus energy. So what is the number of protons and neutrons for R? So the number of protons is 92 and the number of neutron is 233, that is the nuclear number minus proton number, that is 92. So the number of neutrons comes to be 233 minus 92, so 141. So 141 and 92. So the answer is A. Question number 39. The diagram shows the quark composition of 4 different hadrons. So 4 different hadrons. One of the hadron is this plus particle and it has a charge of plus E, where E is the elementary charge. Which hadron could have this particle? So we know that up, top and charm have a charge of plus 2 by 3e, while down, strange and bottom have a charge of -1 by 3e. So to form a charge of plus e, that is plus e, or you can say that 1 plus e or 1e. So 1e is formed by option D, that is up and strange. Up, that is plus 2 by 3, plus 2 by 3e, plus 2 by 3e, that is up plus up, and strange is -1 by 3e, so -1 by 3e. So after calculating, we get a value that is 2 by 3 into 2 minus 1 by 3. So we get a charge that is plus 1e. So their charge is plus 1a or 1. So the correct answer is D. That is up and strange. Which type of particle is comprised of most quarks? So antiquark. Antiquark is any antiquark that is up, strange, down, top, bottom, charge. These are the antiquark, that is one antiquark. Then baryon. So here we can see that particles are made up of hadrons and leptons. So leptons are not made up of quark and not affected by strong nuclear force, while baryons are made up of 3 quark and mesons are made up of 2 quark. So meson can be matter or antimatter, and hadrons are made up of quark and are affected by nuclear force. And for the second part, here up, top and charm has a charge of plus 2 by 3e, while down, strange and bottom have a charge of negative 1 by 3e, and up and all have a mass of u by 3. So first of all, here we can see that particles are divided into leptons and hadrons. So leptons are not made up of quark, while baryons are made up of 3 quark and mesons are made up of 2 quark. So leptons are not made up of quark, mesons are made up of 2 quark and baryons are made up of 3 quark. So the most number of quark is in baryon, that is option B.